So exam 1 review part 2 of calculus 2. So we evaluate the following limit. And question number 1 is limit as x approaches infinity of x to the power of 3 over 2 sine of 1 over x. 1 over x is the argument of sine. So for this, we first of all do the inspection because we cannot simplify fast. And we find that if you have to substitute x with this number, we have infinity. And then sine of 1 over x. 1 over a big number goes to 0, and sine of 0 equals to 0. So this is in the indeterminate form of this type. So we have to make sure that we change this type to be a type of 0 over 0 so that we can use L'Hopital's rule. So for that being said, so we will have limit as x approaches infinity. Then we have sine of 1 over x. That one will give you the 0 in the numerator. Then if we divide by 1 over x to the power of 3 over 2, it's the same as saying limit as x approaches infinity of sine 1 over x. Then this divided by x to the power of minus 3 over 2. Now with that, we can use L'Hopital's rule, which tells us that the limit of this function is the same if you find the limit as x approaches infinity of the derivative of sine 1 over x, which is chain rule. And as we agreed, we start by finding the derivative of sine, which is cosine, fixing the argument. Then you multiply by the derivative of the argument, which is now minus 1 over x squared. If you do the quotient rule, or if you use the power rule of 1 over x, which is x power minus 1. Then the derivative of the denominator will be minus 3 over 2 x to the power of minus 5 over 2, because you're subtracting 1 to get a new power. Now, minus and minus will cancel with each other. So cleaning this, we have limit as x approaches infinity of 2 over 3, because it's 3 over 2 in the denominator. Minus and minus will cancel, and we'll be having cosine of 1 over x as a numerator function. Then you'll be dividing by x squared times x power minus 5 over 2. So this is the same as limit as x approaches infinity, 2/3 times cosine of 1 over x divided by x to the power of minus a half. Again, you can write this one as 2/3 factored out, and then the limit will operate on this function, limit as x approaches infinity, cosine of 1 over x divided by x power minus a half. So the limit rule, we say that you find the limit of cosine 1 over x as x approaches infinity, divide by the limit as x approaches infinity of x power minus a half, or better say, 2/3 limit as x approaches infinity of x power a half multiplied by cosine of 1 over x. So if you were to substitute x to the infinity to simplify, to see this answer, you get 2/3. If you substitute x with infinity, you have an infinity multiply cosine of 1 over a big number is cosine of 0, which is 1. And using L'Hopital's rule, we say that we use until we get to reach up to a point of the answer. If you get infinity, then that will mark the end of the road. And then that means that the limit as x approaches infinity of this function is this. infinity. So let's do number 2. So limit as x approaches infinity of x power 1 over x. So I'm having an exponential function. So as usual, I'll try to rewrite this by letting y to be equals to x power 1 over x. And then if I introduce natural log of on both sides, I'll have natural log of y equals to 1 over x, natural log of x. There I have applied the property of natural log whereby you drop the power. And going back to the limit question, we have limit as x approaches infinity of x power 1 over x is equals to, now limit as x approaches infinity of y. And don't change the question. We have this one becomes limit as x approaches infinity. Exponential natural log of y is still y, but now our y it's natural log of y, like that. So this becomes limit as x approaches infinity. Exponential natural log of y, it's written in this form, ln of x divided by x. So all those are the same. And now if we are to find the limit, if you are to inspect this problem, we have that the limit will operate here, and I'll have exponential now to the power limit x approaches infinity of ln of x divided by x. That's a property of limits. So from here to here, we apply that property of limits. So now we get this as exponential limit as x approaches infinity of ln of x. If you have to substitute with that infinity, you get infinity over infinity. So it's indeterminate. So you find the derivatives of ln of x. So you have limit as x approaches infinity. Derivative of ln of x, it's 1 over x. And then the derivative of x is 1. So dividing by 1. Now, if you substitute this big number, which x is approaching, you get 1 over a very big number, which is equals to 0. And any number power 0 is equals to 1. Number 3, same thing. We let y to be equals to 1 plus 1 over x to the power of x. And then we call this natural log of y by introducing natural log on both sides is equals to, using the properties, x natural log of 1 plus 1 over x. Now, then this one becomes the limit as x approaches infinity of 1 plus 1 over x to this power x is the same as limit as x approaches infinity of y. And without changing it, then we introduce exponential then to the raised to the power of natural log. Limit as x approaches infinity, it's exponential natural log of y, which is still y. And then this is the same as limit as x approaches infinity of exponential natural log of y, it's ln of x with an x. So it's x ln of 1 plus 1 over x. Becoming, using the properties of limits, exponential, then limit as x approaches infinity, x natural log of 1 plus 1 over x. If you substitute x by infinity, you get a type of infinity times, you have an infinity there. If you substitute infinity times ln of 1, which is 0. So infinite, this indeterminate type. So we need to make it a type of 0 over 0. So this becomes exponential limit x approaches infinity ln of 1 plus 1 over x, because that's already a 0. If you substitute infinity, then you divide by 1 over x. Now, using the L'Hopital's rule, we have this as exponential limit x approaches infinity. Let's find the derivative of the numerator, ln of 1 plus 1 over x. So the derivative using chain rule is the derivative of the inside part of ln, which is minus 1 over x squared, divided by that in a function, 1 over x, 1 plus 1 over x, sorry. Then the derivative, let me drop this exponential. So to be here. Then over the derivative of this, which is minus 1 over x squared. All this is in the power. Now, this will cancel with that. And you have this as exponential limit as x approaches infinity of 1 divided by 1 plus 1 over x. Now, if you are to do the inspection again before you move to the next step, if you substitute x with this big number in infinity, you get 1 over x over big number that goes to 0. So then 1 over 1 is just 1. So the answer becomes e power 1, which is e. Finally, for this part 2, we do the limit as x tends approaches 4 of this radical of x squared plus 9 minus 5, x squared plus 9 square root, then minus 5 divided by x squared minus 16. The step number 1, it's always to try see whether you can simplify. So to simplify, here you use conjugation. Or you rationalize. So to rationalize here, you multiply by the square root of x squared plus 9 plus 5, both denominator and the numerator. Then this becomes limit as x approaches 4. Then looking keenly, if this one was A and this one was B, then the same, this one should be A, this one should be B. And that is A minus B, A plus B, which is square of A, because it's a difference of two squares, minus 5 squared. Then you divide all that by the denominator, which is x squared minus 16, then multiply by square root of x squared plus 9 plus 5. So this one, simplifying further, you have limit as x approaches 4 of the square of the square root is now x squared plus 9 without a square root minus 25. This divided by x squared minus 16 square root of x squared plus 9 plus 5. And this becomes limit as x approaches 4 of x squared minus 16 divided by x squared minus 16 x square root of x squared plus 9 plus 5. So we cancel that. We have now the result as limit as x approaches 4 of 1 divided by square root of x squared plus 9 plus 5. And then if you substitute x with 4, you have 1 divided by 4 squared, that's 16, plus 9, that's 25. So root of 25 plus 5, which becomes 1/10. That's the end of part 2.